All right, folks, we're back, and in this episode, we're going to dive a little bit deeper into some stuff we've already discussed, but really explain some of the whys of what plays into the pricing and your individual tooling costs. So just real quick, you have raw materials, you have tooling prices that are really amortized over, could be several years, several cycles, and then you have the individual labor to either load the material into the hopper, which goes into the machine, and then extract the part, whether that's via automation and you're quality controlling, putting things in boxes, or physically removing the part from the drop or wherever it comes out of the machine. And then warehouse operations, the quality control people, the people in your front end office, like all that plays into it. And I think what I'm trying to do in this episode is really give somebody an audible explanation if they were to walk into warehouse and they see all these individual people walking around, where that payroll comes from. And then some of the like changeover operations that would affect the costs. So let's look at people on the floor. Let's just say an operator. And maybe there's operators, there's likely somebody on the floor that's in charge of that whole shift.
Yep.
And then I often see material handlers, warehouse guys, and then a quality control person.
Yep.
Who else could there be?
Yep. I mean, that hits most of it. But yeah, you've got a supervisor, you got material handlers, you got a warehouse guy, and you got operators, and then quality. So the material handlers are just moving material, making sure that the machines have the correct material and an abundance of it, so you don't want it to run out. So what's really driving your costs, you got two separate buckets. You've got your overhead, indirect costs, and then you got direct costs. And your direct costs are going to be raw materials, boxes, anything that you're going to physically see and touch with that part. And then you've got your operator costs that is tied to that. And a lot of times you'll see like your operator rate. You'll very rarely ever see just one operator per machine. Usually it's like, hey, we're going to throw this part only requires a third of an op. So that means they're probably running 2 machines or more.
I'm going to describe that from my point of view. Mm-hmm. So I walk into the factory. My only concern is my part, and I'm watching that, and I'm noticing people going from our conveyor belt to another company's conveyor belt, or another,
Yep.
Another me,
Yep.
who's not there, and then sometimes a third other company, and they're pulling parts off the conveyor belt. And it took me a while to understand that once the conveyor belt is loaded, it has to go through a certain point before it can be removed off the conveyor belt, which, as we've discussed previously, all has to do with the cooling down effect of the part. Like you can't pull it straight off, or else you're going to have quality control issues. So knowing that there's a certain time frame of which parts can build up on the machine before it actually gets put on the box allows that person to, instead of just standing there with their hands in their pockets, to go do some of these other tasks that need to be done.
Yeah. Well, and they don't want to sit there either, right? So they need to fill their time. So what better way than just say, hey, go run these 2 other machines. Operators are not, they will catch quality issues, right? They're
First line of defense.
They're the first line of defense. If they see, hopefully they're looking up the conveyor and watching stuff actually come off every so often and saying, hey, I'm seeing this, and they're alerting their supervisor or manager and saying, hey, I think something's wrong on this machine. It's not, these parts don't look right.
Which could be a calibration issue, a feeding issue.
Yep. I mean, it could be a million different things, but they know what these should be looking like. They should have photos of good, bad, ugly, and everything they should be looking for. And then, they're kind of the defense in between when quality's walking around and doing their hard checks.
And so to me, quality is coming out of the quality control room, because it's a whole room. Mm-hmm. And I've seen that every factory I've been in. There's a dedicated room. Quality control person will come out. They will grab a part randomly from near the boxing area.
Yeah.
They'll take it back. They'll weigh it. They'll measure it. They'll sometimes put it on a spectrogram or something to check the color. They're
also checking cycle times for the molder's benefit, making sure that they're staying within that standard cycle time that we've processed out at. So that's for profitability reasons. So they're doing the whole gambit. They're checking for the customer, but also for the facility that they're working for to make sure that they're staying profitable.
Material handlers / warehouse. I've seen it in some facilities be one and the same. I've seen some forklift drivers, for instance, just load material and bring pallets and bring boxes and basically keep the engine running.
Yeah.
And the other cycle to that is they'll take the boxes, put it on the shrink wrapper, put it in the warehouse. They're loading trucks. They're checking that back end.
Yeah, material handlers and warehouse managers are usually talking to each other quite a bit during the day. They're saying, hey, material handlers got a little bit extra time. They're going to take something back to the warehouse. They're talking to the warehouse. Hey, where do you want this? What lane do you want it in? What rack do you want it in?
There's always something to clean.
Yeah, we've always told people, hey, if you've got nothing else to do,
grab a
broom because there's pellets everywhere and it just doesn't look good. So,
and that is the remarkable thing I've always thought. No matter what injection molder I've ever been to, small, big, medium, whatever,
clean, dirty,
it's almost always universally clean. Mm-hmm. We get that microplastics. They don't want pellets laying around because every pellet is worth something.
Yeah, and it's also a hazard. You can slip on those things. So, yeah, we've always told people, if you've got nothing else to do, just grab a broom and start going somewhere. So, but I've been in facilities where it's like, do you guys own brooms? And I've been at other facilities where I'm like, I could eat off this floor, and you're usually paying for that. And there's usually a reason why they're so clean. They're doing some higher end stuff.
I've also been struck by, there's all these people working, but given the size of these facilities and the enormity of some of these machines, it's a lot less than what you would think.
Meaning what?
Meaning, I am estimating that for every 3 presses, there's 1 worker.
Yeah, that's kind of how we'd like it to be 1 for every 4. If you've got the right people that can do it.
Or if you have more automation. If automation was on every single one, you probably could.
Yeah. I've actually had an employee that was working 6 machines at once and leaned, like it allowed for it, right? It's
simple parts.
Yeah, very simple parts. They were stackable, very easy molding. But I've had employees that were working 6 to 8 machines at once, which is crazy to think. But yeah, labor. You want to minimize labor as much as you can as a molder, as a manufacturer. And that's not because we hate people. It's because you want to hire the right people that are going to do the right things and do the quality checks and look for
and keep up your company culture without being a cancer to it.
Right. So we get into these operations and we want to create jobs, but we want to create the right jobs for the right people.
I should say at this point, all the employees that we've talked about so far could be overnights, weekends, 24 hours a day. There's different shifts. And again, some factories run 12 hours, some run 24 hours. Then there's more Monday through Friday types, of course, administrative, people answering the phones, the freight kind of people, which sometimes are all one and the same. But then I've also seen like the people that make sure the tools are functioning and repaired and stuff like that. That's not happening overnight.
No, normally that's all daytime stuff, but I have seen it where you've got tool makers overnight that are usually a lot bigger operations, and they'll keep them on nights just in case of emergency type situation. They're obviously doing all their cleaning and checks, but for the most part, it's like, hey, if a tool goes down, we can't call Joe again. This happened 3 times last month. We got to get somebody in here full time. So, but that all goes into, I talked about the 2 buckets. You got the bucket of overhead and you got the bucket of direct cost. So all that overhead goes into something they call machine rate or a burden rate. And that's amortized over your part, over your run. And then you've got something like a setup fee, right? So that we've talked about putting the tool in the press, purging.
That's the next thing coming up. So let me just explain to that. I like saying my point of view because the listeners, that's going to be what they see. So you're not buying. Let's say somebody's making bowls. You're not buying a bowl machine. You're buying a bowl mold, and that mold goes into the injection molder machine. For lack of anything else, has a cavity that can accept these different molds.
Yeah,
and the thing that's really important is the bigger the part or the more parts per mold. Let's say there's 2 or 3, 4 parts being made in a single mold. That mold could get very large, which requires a large machine. For small parts, it could be on a smaller injection molder, and there's all kinds of different sizes of those. But that cavity can accept a range of mold sizes, roughly about the same pressures and size. Mm-hmm. But it does require to bring some type of crane, go down, you hook up the mold that was just in there for another company. That includes water lines, cooling lines, actuator, hydraulics, anything like that. It all gets unhooked, it gets pulled out, it gets stored or to tooling or whatever for the maintenance. Once your mold is picked up and hoisted with these cranes, it's dropped into the cavity of the mold and basically suspended by the chains, and a series of gears and I'd just say gears, right? I mean, there's
gears, hydraulics,
all come in and grab the mold and make sure that as it opens and closes, it's perfect.
Aligned.
Yeah. That's a calibration. Then there's also a calibration of the flow rate, possibly the temperature, different material specifications get plugged in. And then once all that's set, your test runs begin in that, hey, enough materials going in to make a complete part. It's not making half, which means the gates are opening and closing correctly. Any actuations are happening correctly. The water lines get hooked up. The hydraulic lines get hooked up, which is why those O-rings are so important. It's getting cooled. There's a lot of heat in this process, and so those water lines are coming and going from a central refrigeration area and basically cooling down the machine.
Yep, the tool.
So that's that part of it, but there's a secondary thing that happens if you're doing, hey, we're going to run a bunch of green parts and then we're going to run 10,000 white parts. Between green and white is the purge, in which you run the green colorant out and you introduce the white colorant until it's within spec. And usually that takes 20 to 50 runs.
Yeah, it depends. I mean, you can use 10 shots is usually a good.
And it's wasted material, and every shot is a few seconds, and those seconds all add up.
I don't know if I've said it in the podcast, but how I look at it from my perspective is I'm not selling you parts, I'm selling you time on my machines.
Which is the third cost we were going to discuss, but yeah.
So those seconds that you're talking about when you're purging stuff out is what you're paying for. We call those setup costs. So normally there's a standard charge depending on the size of the tool. It's a charge of anywhere between $500. I've seen it upwards of $1,200 per setup charge, and that's amortized over your entire run. So,
which is why you don't want to do short runs.
Right.
And that's also why you can't call up your molder and go, hey, I'm out of stock. Can you print me 50?
Yeah, it's like, well,
I shouldn't say the word print.
It's fine.
I don't want people to get the impression
it's not 3D printing.
Yeah, that's it.
It's fine. Yeah, can you run me 50 parts? No. Call it 100 parts so it's easy math. And if your setup charge is $100, it's going to be $1 per part. Well, if those parts cost 50 cents for material and labor and everything else that you're paying for at 10,000, if you cut a PO for 10,000, it costs 50 cents a part, and all of a sudden you just need 100. Well, your cost just went up $1 per part.
Well, also you guys have to schedule these runs.
Mm-hmm.
And so if you get a favor done, just know at some point in your career, your stuff is going to get taken online for a favor for somebody else. That's just part of the game. But it doesn't happen that often. It can't. There's no way. Because if you're, what's a typical, like the minimum run that you would do for a part? Like this is average. My
minimum order quantities on just about everything is 2,000.
I'm surprised it's that low, to be honest with you.
Yeah. Well, I've got quite a few customers that are, they run 10,000 of these a year. And so normally I base it on quarterly. So I just say, hey, my MOQ on everything is just going to be 2,000. That gives them a good enough run to amortize a setup cost. And so it gives them a good price. But then I'll also offer, hey, if you want to buy 10,000, you're going to be paying 40% less. So it's for cash flow purposes, sometimes they take the 2,000, pay a little bit more, or hey, I really want to capitalize on that lower cost. And then that's a win-win because
I've seen times where a mold is in there for days and days and weeks.
Months. Yeah, I've seen some of your parts that have been in for a month. I mean, that's a lot of cycles. That's the goal, man. That's what we want to do. 24 hours a day, 5 to 6 days a week for weeks on end. That's what we want.
There's also a cost. So you said 5 days a week. So sometimes that you do run 5 days a week. To shut that down and to restart it up, what's that look like?
It's a pain in the butt. It's a 6-hour ordeal.
Because you can't leave anything in the mold.
No, you got to purge all the barrels out. There's a lot of electricity that's involved in heating these things and heating these machines up. So you've got a manager or supervisor coming in 3-4 hours before anybody else gets there, and they're turning on all the machines, getting the lights on, making sure the coffee's ready to go, keeping the employees happy. It's an ordeal. So it's not something like, hey, can you work this over the weekend? If we're scheduled, maybe, but if we're not scheduled, this isn't a one-man thing where we don't allow one person in there at a time anyway. It's just a safety thing. Things can go wrong. So yeah, it's a half day just to get stuff up and rolling. 3 hours to me is half day.
All right. So again, that was just a little bit of a deeper dive onto some of the complexities in the day-to-day operations that I've been able to witness over the time, and I hope that helped you out. Up next, we're going to talk about why, as a small business or even a large business, you still need an injection molder instead of having a molder itself.